Hi, I'm Ling Yuan, application scientist here at LI-COR. Today in this video, I'm going to talk about the Bryophyte chamber. I will first talk about the chamber installation, and also we'll also talk about the light source if you have the light source available, and also give a brief overview of the software changes after the installation and things you may want to keep in mind. Okay, here I have the Bryophyte chamber over here, and the light source with the light source adapter over here, and my sensor head. So the tool you will need will be just one long screwdriver. This is provided in your spare parts kit, and also a small Phillips screwdriver. So that's all you will need. So first I will so we will need just remove whichever chamber that is currently installed into your sensor head. Now I'm having the fluorometer. To remove the fluorometer, so first remove the cable from the clip. And then you can remove like the screws, 4 screws, like one screw from here, one screw from here, and 2 captive screw, one over here and the other over here. So first let's detect a couple of connectors first. So you can flip the sensor head over. So this is the connector cover. So remove this connect cover if it is there for you. So use the small Phillips screwdriver. And this can be detached. Then disconnect the external quantum sensor connector from the PAR port underneath the sensor head. And then disconnect your thermocouple connector from either T1 or T2 port. T1 and T2, they are exactly the same connector that can use for connecting your thermocouple. So I will detach it from my T1 connector. And now I will go ahead to detach the screws on either side of the sensor head. So for this screw, you can use either the small screwdriver or the long screwdriver. So one on this side and the other on this side. Okay, and the other 2 screws are captive screws. So you will just need to loosen them enough to detach the whole chamber. So you really don't need to completely detach these 2 captive screws. So just loosen these 2 screws. Okay. And this chamber can be detached. Okay, let's set this aside. And now, before we install the Bryophyte chamber, let's briefly talk about this. So this is your Bryophyte chamber adapter, and this is your bottom plate, and this is your top cover. So for the bottom plate, you see on one side it provides a shallow wire, and on the other side, you see you can install a screen, to this side. So, this provides 3 options for loading a sample. If you want to load your sample in the shallow wire, you just go ahead to install the bottom cover like this way, and then you can load your sample in the shallow wire. But you have other 2 options. You can put your measurement sample on the screen. So currently the screen is installed on top of the short riser or spacer, but you have the option to use a longer or taller spacer. So you just remove the 4 screws and replace the short riser with the longer riser, and then put the screen in between the 2 washers for each for each of the 4 sticks. So for today, I will just use the screen with the short riser and install this to the bottom part of the chamber adapter like this. Just use the screws provided, the 4 screws provided for installing the plate. Okay, then you should tighten the screws snugly. Hand tie should be fine. Just make sure the chamber is sealed so you don't have any leaks due to the chamber installation. Okay. You have already installed the bottom part on the bottom plate of the chamber. And now you can install this the chamber onto your sensor head. Okay, and then just like this, and tighten the 2 captive screws, 1 on each side. Okay, and now you can either go ahead, load your sample to the chamber, and then put the top cover on and use the ambient light conditions for your measurements. So the Bryophyte chamber features the clear proper film on top, so you use the ambient light conditions, but you have the option to use the controlled artificial light source for your light control, for your measurements. So if you have the light source available, so you can install the light source onto your top cover of your Bryophyte chamber. The light source is a 6x6 red, blue, and green and white light source. So it comes with an adapter. So install this adapter to the top cover of the chamber first. So you can just lay them on top of each other like this, and then use the 4 screws provided with the light source, and then to hold the top cover of the chamber onto the adapter. Okay. Now you can position the light source onto the adapter. So see, the adapter has a square corner, so the cable of the light source should line up with the square corner. Okay. See, this is the square corner of the adapter, and this is source connector, the cable, and just the corners should line up with the cable like this. Okay, and then the light source comes with 2 captive screws, so just tighten these 2 captive screws like this. So finger tight should be fine, but you can also use a flat screwdriver to help with the installation of the light source. Okay, I think now it's secure and safe. Now you can, after you're loading your sample, you can put your cover and light source on to your chamber, and then you can connect your light source connector to the one of the ports underneath your sensor head, which is labeled as LS, light source port. Here, this one. So just line up the two red dots on the connector on each side. Okay, if this is not easy for you to do this, you can lay the light source down. Okay, make sure they line up very well before you push in. Okay, and also make sure you remember to connect the external quantum sensor connector back. So this should be plugged into the PAR connector, the underneath the sensor head, this here. Okay, and this is how you install the Bryophyte chamber with the light source, if you also have the light source available. Next, I will give a brief overview of the software changes after switching to the Bryophyte chamber and things to keep in mind while using it. Power on the LI-6800 if it is not already on, and verify the instrument recognizes the chamber automatically under Startup Chamber Setup screen. If you see the chamber info on your right-hand side and there's no warning in red showing up on this screen, that means your chamber is recognized. An important consideration when computing fluxes is a metric by which to normalize the fluxes on an area-based basis or on a mass basis. Area-based fluxes will normalize to leaf area with fluxes in units of micromole per square meter per second for simulation and mole per square meter per second for transpiration, with the user entering area in square centimeter. Mass-based fluxes will compute fluxes in units of micromole per kilogram per second for assimilation, and mole per kilogram per second for transpiration, with users entering mass in grams. So you can choose whether to compute area-based flux or mass-based flux based on your own requirement. If you are computing fluxes on the basis of mass, weigh your sample and make a record of the mass. For area-based flux, determine the sample area and then make a record for the leaf area. Then you should go to constants and then gas exchange screen to enter either your leaf area or your mass. Besides, after the chamber installation, if you want to verify your installation to see if the chamber is sealed well, you can go to warm-up tests and then pick the individual test named chamber leak test and run this test only to verify if the installation is good or not. The whole warm-up test is a daily test. We suggest you run that every day after you turn on your instrument before you run any measurements. But to verify the installation only, you can only run the chamber leak test. Besides, with Bryophyte chamber, the leaf temperature requirement is defaulted to energy balance. If you go to constant leaf temperature, and the leaf temperature won't be measured by thermocouple. Two more things I would like to point out are related to environmental controls. One is flow setting, and the other is light setting if you have a large light source available. Actively transpiring leaf material or huge water flux in the large chamber volume will add water vapor to the chamber air, thus raising the humidity levels. As air leaves the leaf chamber and enters towards the sample cell, it is exposed to near ambient temperatures. And condensation is a risk if the chamber temperature is elevated. Care must be taken to avoid condensation in the chamber, and especially condense the water into the optical path. Our system is designed to prevent condensation under typical measurement conditions. For example, a high humidity warning appears when the RH is higher than 90% in the chamber or either of the agar cells. If the RH exceeds 99%, the auto-dry program is launched to bring down the humidity and prevent condensation. A user should train your eyes towarding to the left top corner of the screen for the warnings, and let the auto-dry run and finish whenever it is triggered. Besides, we will recommend avoid a big temperature drop of sudden. In addition, using a relative higher flow rate like 800 to limit time residence of the water vapor in the chamber can also help eliminate condensation risk and flush the big chamber volume quicker. For the light source, if you have it installed or available, the system should detect the light source automatically and also power it on automatically a few seconds after it is connected. If this is your first time using the light source, you can adjust the red, green, blue, and white light ratios to get a sense of how they work. Then you can set red 9 and blue 1 to provide 9 parts red and 1 part blue if you would like to. This is a typical ratio for gas exchange measurements, but set up your light ratio based on your own needs. We have other videos and resources available on our support website, so you're welcome to check them out. As always, if you have any questions, please don't hesitate to let us know or contact your local distributors. Thank you.